Hey guys, today we're going to be finishing up 8-5 and we're going to be talking about something called a complex fraction, which is exactly what you think. A really big fraction that's pretty complex. So the aim of today is going to be to simplify them, to try and reduce them as much as we can. So right in our do now, we actually have a complex fraction. We see in our numerator, we have x over 3. We see in our denominator, we have 7 over x squared, right? And we have the fraction bar in between. Hopefully we remember that a fraction bar is another way to show division. Okay, so if we ever see fractions within fractions, what we can do is we can think of the larger denominator divider as a division symbol. So we could actually rewrite this question as x over 3 divided by 7 over x squared. Now, we have already talked about division before, right? We know with division, we're going to keep the first fraction, we're going to change to multiplication, and we are going to flip or find the reciprocal of the second fraction. So if we wanted to compute this, we would get x over 3. We would multiply it by x squared over 7, leaving me with the final answer, x cubed over 21. Okay, now looking at the original question, we could actually skip over this first step of rewriting it as division if we think of it as keeping the numerator, changing this division symbol to a multiplication symbol, and flipping or finding the reciprocal of our denominator. Okay, now this one's not too bad because both numerator and denominator are only composed of a single fraction, but that will not always be the case. It is very possible and often common to have addition and subtraction within the complex fraction itself. So here we have x over 2 minus 8 over x in my numerator. We have a bigger fraction bar, and we have 1/4 minus 1 over x. So now if we think of this question as a division problem, right, a larger division problem, it's like we are going to take this numerator subtraction and divide it by this denominator subtraction. Okay, so what basically has to happen is we can handle this subtraction first, then handle this subtraction second, and take their resulting answers and divide them. So if we remember from last class, to subtract fractions, we need to make sure we have the least common denominator. So looking at this x over 2 minus 8 over x, what we should see is that my least common denominator here will be a 2x. So if I multiply this first fraction by x over x and this second fraction by 2 over 2, right, we get x squared over 2x minus 16 over 2x, which simplifies to x squared minus 16 all over 2x. So that's my first set of computations. Now we look at our denominator and we handle that separately, right? Again, we need our least common denominator, which in this case is going to be a 4x. So if I multiply this by x over x and this by 4 over 4, okay, what we get would be x over 4x minus 4 over 4x, leaving me with the larger fraction, x minus 4 over 4x. Okay, now we know that there is a division sign in between these, right? Because one was our numerator, one was our denominator. And so with division, we know to simplify, we keep the first fraction, we change to multiplication, right? And actually, I'm going to use a dot to represent multiplication. And we flip our second fraction. All right. Now, when we're working with multiplication, hopefully we also remember, right, now we have to make sure everything is in its factored form. So if we look at x squared minus 16, we know we can factor that as the difference of two perfect squares to x plus 4, x minus 4. okay? And then from this factored form, we can do any cross-canceling that we may have. So x minus 4 can be canceled. 2 and 4 can be canceled. And x can be canceled, leaving me with 2 times x plus 4 in my numerator, and actually no denominator in this particular question. I could also represent this as 2x plus 4 as my final answer. Okay, now that's a lot of work. It's almost like 3 questions in one. We have our numerator question, we have our denominator question, and then we have the division question, which turns to multiplication. So there's actually an easier way to go about doing this problem. Instead of handling it in separate cases, we can handle them all at the same time using the same idea of least common denominator. Okay, so the second method for complex fractions and simplifying is to multiply by not just the LCD of each individual part, but the LCD, least common denominator, of every single fraction. So if we take a look, we have x over 2, 8 over x, 1 over 4, 1 over x. The least common denominator for every single fraction here would be a 4x, right? Because we can multiply each of these individual denominators to get to 4x. Okay, so we have our least common denominator. And what I'm going to do is I'm going to multiply everything in my numerator by 4x and everything in my denominator by 4x, right? So in theory, I'm multiplying every single one of these fractions by 4x. So you'll often see me write next to each individual fraction so I can do my cancellations. So let's see what cancels. Well, in the first fraction, 2 and 4 cancel, leaving me with just a 2 there. In my second fraction, in the numerator, the x and the x cancel. In my first fraction, my denominator, the 4 and the 4 cancel. And in the second fraction, we have the x and the x canceling. Okay, so what actually happens when we multiply by the least common denominator is that every denominator drops out, right? We get rid of the 2, the x, the 4, and the x in all the individual fractions, and we are just left with their numerators. So for this case, we have 2 times x, which is 2x squared. In the second fraction, we have just 4 times 8, which is 32. And in my denominator, I have x times 1, which is just an x, and 4 times 1, which is a 4. So now we've eliminated all of these complex fractions into one simple fraction that we can reduce. Okay, now we reduce the same way we've reduced every other question. We factor, so in this case, we factored GCF, and then we factor the difference of two perfect squares, so plus 4, x minus 4. And then we cancel out any factors. So in this particular case, x minus 4 and x minus 4 cancel, and we end up with 2x plus 4, which is exactly the same answer as we got above. So looking at these two methods, if you stay organized, this method number 2 is going to be a bit easier because it's going to eliminate most of the fractions you're working with. Actually, they're going to eliminate all the individual numerator and denominator fractions and just give you one big fraction. Whereas the first method that we did above, it's a little bit more complicated because you have to work with the numerator fractions, denominator fractions, multiplication of fractions. It's a lot less steps to follow this method. So I encourage you to do method 2. Multiply by the least common denominator of every single fraction so that we cancel things out and we have simple simplifications. So let's take a look at this question. All right. So we have a big fraction bar here, and we have two additions in the numerator and the denominator. So if we just look at every single denominator, x, x, y, y, if we identify our least common denominator and multiply every fraction by it, we should get cancellation. So my least common denominator here would be x times y. Okay, so I'm going to multiply every fraction by x times y, x times y, x times y, x times y. Okay, now we work on our cancellation. So with this first fraction, x and x cancel out, leaving me with 2y. In my second fraction, y and y cancel out, leaving me with 3x. In the first on the bottom, x and x cancel out, leaving me with minus 5x. And in the second fraction, y and y cancel out, leaving me with 7x. Now, if there were any factorings that can be done, we would do that. But there's nothing in common in my numerator, nothing in common in my denominator, so we can leave this question as is. Okay, so the LCD method is going to be a bit simpler for these kinds of questions. Okay, so we're just going to work on two others that are going to require a little bit more of the factoring idea. So if we take a look at this first question over here, we're asked to simplify. What we should notice is that now our denominators are not just individual values, but instead we have our binomials. A plus b, a minus b, and a squared minus b squared. If this is the case, it should be our first instinct to factor anything that is possible, because that is going to help us find our least common denominator. So a squared minus b squared, although different from what we've typically looked at, actually factors to a plus b, a minus b. Okay, so we're replacing this denominator with this new factored form. And now, given that information, we can find the LCD of all the denominators and multiply by that value. So we have it. If you remember from yesterday, the LCD is made up of one copy of every factor in our denominator. So we need an a plus b, we need an a minus b, and since both of those are repeats in the denominator, that's the end of my least common denominator. All right, so looking at this big fraction, multiply by a plus b, a minus b, multiply this fraction by a plus b, a minus b, and multiply this bottom fraction by a plus b, a minus b. Okay, now we try to cancel out. In the first fraction here, a plus b will cancel out with a plus b, leaving me with 2 times a minus b. In the second fraction in my numerator, we cancel out a minus b with a minus b, leaving me with plus 2a plus b. And in my denominator, a plus b cancels with a minus b. A plus b and a plus b and a minus b and a minus b all cancel out, meaning the entire denominator goes away, and we are left with just the numerator of 4. Okay, so now from this point, right, we see an addition symbol. So that means we have to simplify as much as possible to get into a form that we can check for factorings. So we distribute our 2's to get 2a minus 2b plus 2a plus 2b all over 4. The minus 2b and the plus 2b will cancel, and the 2a's will get 4a, and lucky for us, that cancels out to just an a. So our final answer after all that work is just a. Okay? So take a second to try the last one. Pause the video for a minute or so. Get your thoughts together. Remember, multiplying by the LCD, and then canceling out, and then simplifying. When you're done, unpause it and check your work. All right, so looking at this fraction, let's get a good zoom. So looking at all our denominators, now there's something different in this particular fraction, okay? In this particular fraction, we have 2 whole numbers. But what we want to remember is that when we have whole numbers, their denominators are 1, okay? So we don't really need to worry about it because anything times 1 is itself, but it's important to understand that those are numerator values over 1. So we look at all of our denominators. What is the least common denominator of everything we have there? Meaning, what is something all of these divide into? And that would be x squared, right? 1 goes into x squared, x goes into x squared, and x squared goes into x squared. So we're going to multiply the entire numerator by x squared, so that's each fraction. and the entire denominator by x squared, which is each fraction again. So what do we get? Let's do our canceling out. So here for the first fraction, there's a 1 in the denominator, so there's nothing to cancel out. We get 2x squared. Okay. In the second fraction, so that was the first, here's the second. X cancels out with x squared to leave me with just a single x, and we get minus 7x. In the third fraction, x squared and x squared cancel out entirely, and I'm left with minus 4. Okay, now we work on our denominator. X squared and x squared cancel, leaves me with 1. There's nothing to cancel for that denominator, so I'm left with minus 4x squared. Okay, so that is the process of doing the complex fraction. Now we have to see if anything can be canceled out. And of course, that requires us to do our factoring techniques. Now, unfortunately, this numerator is not the prettiest of quadratics to factor. We have a coefficient of x squared that cannot be divided out as a GCF. So we're going to need to use a times c factoring. So I'm actually going to do this on the side. So a times c is minus 8. We're looking at the factors of minus 8. That will add up to a negative 7. Those two numbers would be a minus 8 plus a 1. So I get 2x squared minus 8x plus 1x minus 4. And we're using grouping here. So GCF of 2x. I have an x minus 4 left over. No GCF in the second one, so I put a 1. X minus 4. And so that numerator factors to x minus 4 times 2x plus 1. Okay? So x minus 4, 2x plus 1. In my denominator, I have a difference of two perfect squares. So 1 is a perfect square, 4 and x squared is a perfect square. So this factors to 1 minus 2x, 1 plus 2x. So now we look, can any of these factors be canceled? And we know because of the commutative property that this can be rewritten as 2x plus 1. So 2x plus 1 and 1 plus 2x will cancel out, leaving me with my final answer, x minus 4 over 1 minus 2x, as my answer in simplest form. Okay, so now, as long as we get the process down, the rest of it will come with practice. So we definitely want to practice some of these. So I'm going to ask that you, we're going to skip that one, work on these practice problems, okay? Page 539, numbers 22 to 29. Work on those, and we will check them over next time.